Hello, let's continue our Sudoku adventure with X Factors by GDC. So this continues our dynamic fog theme week. I'll go over what that means in a moment. So let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we're placing the digits 1 to 6 exactly once each. Now the Sudoku is only this inside 6x6 grid. We are going to be filling digits on the, or not necessarily just, let's see, we're going to be filling digits. We're going to be filling values into these outside cells. I'm not sure if they're digits or not, but they are not limited to 1 to 6. And they are also not part of Sudoku, so you can repeat in as much as you want within here. And not all of them are going to get filled with values. All right, so let's go over the rules. We do have dynamic fog. What that means is right now most of the grid is covered in fog, so we can't see what's actually in those cells. There could be givens, there could be dots, whatever. And the way we reveal the fog is by getting logically correct moves. So the idea is to discover what a certain cell must be through logic of what you can currently see. And as you reveal that, the setter has predetermined what will reveal when you get those correct. It could be nothing. It could be a whole lot of interesting information. All right. In addition to that, we do have crop key dots. So we're going to have white dots and black dots. You can see half of a white dot here. So the other half is going to be up here. White dots, the digits separated by white dots are consecutive. So if this was, say, a 2, this could be a 3, or this could be a 1 in order to be consecutive. Digits separated by a black dot have a 1 to 2 ratio. So if this was 2 and there was a black dot between them, then this could be 1 because 2 is double 1, or this could be 4 because 4 is double 2. Order doesn't matter, just the fact that one is double the other on a black dot. Now, not all the dots are necessarily given, meaning that if we had a 2, 4 here and there wasn't a black dot, that would be perfectly fine. We're allowed to do that. In addition to that, values outside the grid are going to be equal to the sum of the first n digits in that row or column, where n is the first digit. So let's just use a random example here. Let's say this was 8. The 8 is going to be our sum, and then say the 2 here is how many cells we're going to use in our sum. And so in this case, 2 cells. So starting with the 2, we would use these 2. So this one would be a 2, and then this would be a 6. 2 plus 6 is 8. That would work. Or we could put a 3 here, and that would mean all 3 of these are used to sum to 8. One example would be what, like 1, 4. All right, and that's it. Those are the rules. We're going to have to discover what these X sums are. Maybe some of them will get revealed. We don't know. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So clearly, GDC wants us to think about what's it mean for an X sum to be consecutive with the digit that's next to it. So one thing we need to be careful of is a 1 X sum, can only be fulfilled by putting a 1 here. And vice versa. If there's a 1 here, its sum is 1, right? 1 says use 1 cell, there's already a 1 in it, that's going to be a sum of 1. So we can't use 1s at all here. Now, if I think about this, a 2 would not be a 1, right? So 2 would be consecutive with 3, and that would mean these two sum to 3. So it would be 2, 1 with a 3 here. A 3, you certainly... the problem is that this certainly... You can't have an X sum of 2. It's actually impossible. And so an X sum of 4 wouldn't work. You can't sum to 4 and 3. And I think it just gets worse from there. Like if we try to put a 6 here with a 7, we're now using all 6 cells to sum to 7. It's just getting worse. So the only option is to make this a sum of 3 with a 2 here. And then this has to be a 1. All right, now that we've put the 1, we've revealed that this 3 is across a black dot. We can't have 3 to 1.5, even with an X sum, we can't have it. So this X sum is going to be a 6. Now, this has to be a 6X sum, but this value can't be a 2. So we already know 1's not going to work because it would sum to 1. 2 would work, but there's already a 2 in the row. And 4 would be too big because the minimum sum of 4 cells is 10. And so, 1, 2, 3, 4 is 10. And so this has to be a 3, and then this is going to be a 1, 2 pair with the 2 here and the 1 here. Placing the 1 revealed more. All right. What do we want to do now? Well, 2 and 3 are gone here. So The lowest we'd go is 4, 5. Remember, 1 can't be, I mean, there's already a 1 here anyway, but 1 can't be our number of digits. Unless the sum is 1. But the problem is if this sum was 1, this sum would be 2, and 2 is actually just impossible. So I don't... You see, the problem with using all 6 cells is we know the sum. The sum is 21. And 21 is not going to be able to be doubled, and it's odd, so it's not going to be able to be halved. So this is going to be a 4-5 pair. And this is a 1-6 pair. Now, the absolute minimum I could sum with 4 is 10. And then the absolute maximum I could sum with 5 is 20, because we just omit the 1, and that gives us 20. The entire column adds to 21. 1 through 6 is 21. So that's what it's going to have to be. It's going to have to be 10, 20. So what I'm going to do is I'm going to put the tens digit as a corner mark and then the ones digit as a 0. So this is 10 and this is 20. Or we don't know which one, actually. I could do this. We don't know which is 10, which is 20. But the 20 will exclude a 1, which will be down here. And then the 10 will exclude a 4 or a 5. So these are from 1, 4, 5. Or sorry, a 5. The 4 excludes the 5 and the 6. I said that so wrong. Whatever one is the 4, it'll be 1, 2, 3, 4. And then it'll exclude the 5, 6 down here. And so we know these are from 1, 5, 6 is kind of what I mean. Now, we know that the 5 is going to be in here somewhere. And so the 5's in one of these two. Oh, we know what this pair is. This is a 3, 6. Then down here, this is a 4, 5. We also have these exsums here. Remember, well, yeah. So this white dot is telling us this can't be a 1. Because if this was a 1, this would be a 1, this would be a 2, and a 2 exsum's impossible. How many times am I going to say this in this puzzle? So this is the 1, and that does mean that this has to be the 5, and this is the 4. That means this is 3 and 6. That means this is a 5, 6 pair. We have the 1, 2 here, which are actually resolved. And then here, these are just the 2 is placed. And this is the 3, 4. And then this is the 5, 6. All right, and that makes this the 3, 4. So we are vertically roped, interestingly. So it is possible that this is, well, so one of these is 6 adding to 21. I guess we could say this one is the 20. And this one's the 10. We could do, yeah, the 6 being 21, the other one's going to be 20. And so in order to get to 20, again, we got to put a 1, I guess right here, because this is already a 1. So that makes this the 5, this the 6. This is a 21, and this is a 20. So the 6 does nothing. It's going to sum whatever. The 5, put the 1 there. The rest is whatever. 3, 4, 3, 4, 6 here. That's not a 3. This is just 4, 5, 6. That's not a 6. Oh, up here, I missed this. This is 6, this is 1. All right, seems like always placing a 1 is what reveals more exsums. That's fun. So what's this one going to be? If this is a 4, then we are exactly... in fact, we're always using these 4, and we might include the 6. So this is 12 or 18. So we're either 12 or 18, depending on if this is 4 or 5. 12 cannot double to 24 because 21 is our max. And so 12 would be a 6 and 18 would be a 9. Okay. I'm not sure what to do with that yet. There must be something though. Is there an issue with 6 or 9? Well, one thing I do know is that this is never going to be 4, 5, or 6, right? 4, it has a minimum sum of 10. And so this is a 2 or a 3. Oh, and it can't be 2 either. 2's in the row. So this is a 3. That's 4, that's 3. This is a 5, 6 pair. So these 3 are going to add to either 9 or 10. So they're going to add to 9. So that's 9. This is 18. 18 requires this to be 5 and 4. So that's not 4. And then this has to be, for 9, this has to be 5. That's 6, that's 5. Okay. This is 2, 4, 6. That's not 4, that's not 6. This is 2, 4. 2, 3. All right, what am I missing? No exsums. Are there any exsums I haven't completed? 3, 6, 9, 18 is here. This, yeah, 6, 20 and 21 are completed. The 20 is completed by putting the 1 here. So there might just be some Sudoku I'm missing, like a pair or something. Yeah, we need a 5 in this row. That goes here. Oh, that revealed another black dot. Okay. So if this is a 2, we add to 3. If it's a 4, then we know what we add to. It's a something. 10. 3 or 10. So 3 would double to 6. If this is 3, that's a 2, making that a 3, and this can't be 6. That's not going to work. So this is a 10, with this being 4 and 2. That's 3 and 4. That's 6, 2, 3, 6, 4. And we can just fill what this one is. This is a 5. All right. Fill a big 5 there. Nice. That was a really cool puzzle, GDC. And I loved how the fog was giving us new exum clues as we went, which was always fun to think about. All right. Also, like, it revealed as soon as we needed it, and no earlier. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.